Hi everyone, I am T. Sagar from CSMC section SRT. Today I will explain about the topic functions in C programming. Understanding functions in C programming, unlocking modularity, reusability, and efficiency in your C code. What are functions? The building blocks of C. Functions are self contained blocks of code designed to perform a specific task. Think of them as miniature programs within your main program, each with its own purpose. Modular design. Break down complex programs into smaller, manageable units. Encapsulation. Group related statements improving readability and maintainability. Fundamental. Essential for structuring C programs and managing complexity. Why use functions? Benefits for code organization and reusability. Code reusability. Write a function once and use it multiple times throughout your program, reducing redundant code. Easier debugging. Isolate programs to specific functions, making it simpler to find and fix errors. Improved readability. Well named functions make your code more understandable and easier for others to follow. Maintainability. Changes to one part of the code can be localized to a specific function, reducing the risk of unintended side effects. Declaring and defining functions. Understanding how to declare and define functions is crucial for writing your own modular C code. Function declaration. This is a prototype. It tells the compiler about the function's name, return type, and parameters before it's actually defined. Syntax, return type, function name, open brackets, parameter list. Example, int addition, open brackets, integer a comma integer b. Function definition. It contains the actual code that the function executes when called. Syntax, return type, function name, parameter list, return value, close brackets. Example, int addition of integer a comma integer b, return a plus b. Function prototypes. Function prototype is like a blueprint informing the compiler about the function's existence and a signature before its full definition appears. Forward declaration allows to call a function before its definition in the code. Compiler check enables the compiler to check for correct function calls, including argument types and return values. Modular development facilitates breaking code into multiple files where functions defined in one file can be used in another file. Passing arguments call by value versus call by reference. How you pass arguments to functions fundamentally changes how data is handled within the function's scope. Call by value. A copy of an argument value is passed to the function. It changes made to the parameter inside the function do not affect the original argument. Safer as the original data is protected. Syntax void function of integer x equal to x plus 1 int main int a equal to 10 function of a is still 10. Call by reference. The memory address of the argument is passed to the function. It changes made to the parameter inside the function directly affected the original argument used for modifying original data or passing large structures efficiently. Syntax: void function int star x equal to x plus 1, int main int a equal to 10, function of address a. Return types: functions can compute a value and send it back to the calling part of the program using a return statement. First one, specifying return type. The return type in the function signature indicates the type of the data the function will send back. Second one, the return keyword. It is used to exit the function and send a value back to the caller. Execution of the function stops immediately. Void return type. If a function does not return any value, its return type should be void. It still exits with return or by reaching the end of its block. Scope of variables. The scope of a variable determines where in your program that variable can be accessed or modified. The scope of variables are two types. One is logical variables, another one is global variables. Logical variable. It is declared inside a function or block. It only accessible within the specific function or block. Have a limited lifetime. They are created when the function is called and destroyed when it exists. Example: void my function into local variable equal to 10. Global variables. It is declared outside any function, usually at the beginning of the program, accessible from any function in the program. Have a lifeline throughout the entire execution of the program. Example: into global variable equal to 20. Void my function, open brackets. Recursive functions. Functions calling themselves. Recursion is a powerful programming technique where a function calls itself, either directly or indirectly, to solve a program. First one, base case. A condition that stops the recursion, preventing infinite loops, crucial for correct behavior. Second one, recursive step. The part of the function that calls itself with a modified input, moving closer to the base case. Third one, problem solving. Often used for programs that can be broken down into smaller, similar subprograms. Example: factorial, Fibonacci sequence. Best practices and common pitfalls. Follow these guidelines to write efficient, readable, and error-free functions. Best practices: descriptive names. Use clear, concise names that reflect the function's purpose. Single responsibility. Each function should ideally do one thing and do it well. Limit parameters. Too many parameters can make functions hard to use and test. Comments. Explain complex logic or non obvious parts of your function. Common pitfalls. Global variables. Over reliance can lead to hard to track bugs and dependencies. Side effects. Functions that modify external state unexpectedly can cause issues. No base case. It is also known as recursion. It leads to infinite recursion and stack overflow errors. Unmatched prototypes. Mismatched function signatures cause compiler errors. Thank you.